Network Automation Lab using Palo Alto. Before we start working with automation tools, it's important to understand why automation has become a standard practice in modern IT environments. The first benefit is speed. Tasks that might take hours to complete manually can often be finished in minutes through automation. For example, a script can update dozens of firewalls in a single execution. The same advantage applies during recovery, where automation can quickly restore configurations after a failure or replacement. The second benefit is consistency. Every device receives the same configuration, which helps maintain standards across the entire infrastructure. For example, if every firewall should have the same security profile settings, automation ensures the exact same configuration is applied everywhere. Automation also reduces human error. Simple mistakes such as typos, missing commands can cause service issues. Automated processes help eliminate these problems. Another major advantage is scalability. If you need to deploy or manage tens or even hundreds of firewalls across an ISP environment, doing that manually becomes impractical. Automation allows the same workflow to scale regardless of the number of devices involved. Finally, automation provides an audit trail. Changes can be tracked, reviewed, and documented. For example, when automation is integrated with version control systems such as Git, every change can be recorded along with information about who made it and when it was made. There are several technologies commonly used for infrastructure automation, and each one has strengths that make it useful for different Panos automation scenarios. Terraform is primarily used for infrastructure provisioning and policy as code. Its key advantage is state management, where Terraform maintains a state file and automatically detects and corrects configuration drift. This makes it ideal for environments that require consistency and policy enforcement. Ansible focuses on configuration management and operational automation. Its strengths come from structured and repeatable playbooks that define exactly how tasks should be executed. This allows organizations to standardize automation processes and build trusted workflows that can be reused across multiple environments and teams. For APIs, PanOS provides both REST and XML interfaces. The REST API is the newer interface and uses JSON for requests and responses. It is generally easier to learn, easier to read, and integrates well with modern development tools and automation platforms. The XML API is the original Panos API and remains extremely powerful. It supports a broader range of functionality, including many features and operational commands that may not be available in the REST API. Because of its extensive feature coverage, it continues to be widely used in automation workflows. Finally, SDKs provide libraries that developers can use to build custom automation solutions. Rather than directly working with API requests, SDKs abstract many of the low-level details and provide a more developer-friendly interface. In PanOS automation, SDKs are often used together with XML API, combining the flexibility of custom code with access to the full range of platform capabilities. In this lab, I'll focus primarily on Python-based automations and demonstrate how these technologies can be used to automate real-world PanOS administration tasks. This is our lab setup. This is the firewall that we're going to automate in this lab. As you can see, our firewall has three active interfaces. The first one is the outside interface. It's connected to our internet. And then the second interface is Ethernet 1. This interface is connected to our internal network. What we're going to automate today is the configuration that takes our firewall from only having the management interface configured to allowing users in our inside network to browse the internet. Finally, our final interface, which is the management interface, it's connected to our secure VLAN. In this VLAN also is my host machine and also the automation server. Let me show you. This is the server terminal. Let me run hostname CTL. I'm running a Fedora server. Next, let me show you the server IP address. So nmcli connection show management. Let me just show you the IP address. So grep IP version 4 address. And here you can see the IP address is in the secure VLAN. And then this is the code. Before showing you the code, let me open my div container. Be open in div container. Now it's loading. So all of this code lives in a container. It could be deployed anywhere with Docker. So before starting the code walkthrough, let me tell you about a bit about it first. In this project, we are using a Panowist Python SDK. The way this library works is that it provides Python classes, and then these Python classes model the firewall config tree. You build objects in your memory such as zones, interfaces, all of which are pan devices. And then the library translates those classes into XML config. Then the library uses panpython, the HTTP transport layer, which sends XML to the live firewall, or even Panorama. Both of these have almost an identical architecture and smaller config trees. The library supports both of them, and so does my code with minimal changes, whether you are pushing to a Panorama device group or a firewall VSys. The XML API also changes, the XML API call changes land on the firewall candidate config, and then you can use a commit API call to push the candidate to running. The SDK covers most of the config tree, but not all of it. Partway through this automation, we have hit a gap. The cap is the DNS service routes have no native Python class. The fix is straightforward if you know the Panos XML schema. You build the element tree yourself, target the correct XPath, and then you call the RawX API layer directly. Same pattern works for anything the SDK hasn't modeled yet. So that's it for our introduction. Let me start with our code walkthrough. This is the requirements file. It lists all the packages that this app needs to run the code. And then next here we have our main.py. This file only handles the CLI stuff. This is where everything starts. The job of this file is to figure out what the user asks for and then instantiate the right module and hand off control. It knows nothing about PanOS, it just routes the commands. And then this is our modules dictionary. It maps a CLI name to a class. Right now we only have internet access, but the pattern is built for extendability. Adding another module just means importing its class and adding one line to our plugin registry, which is this one. And then the rest of the code does not change. And then here, this part of the code, that handles the arguments. Here you could see this is the module argument, and then here you have your options. Here you have the step option. If you want to run only a single step of the module, you could use this option. And then you have the interactive one, which will run all the steps, but then it will pause between each steps and wait for you to enter, so it goes on to the next step. And then finally here you have the commit option. When you run this option, it will commit the candidate config. And then here you have this line. This line instantiates the correct module that you defined in your arguments. And then this code below, it takes the instantiated module and then runs the arguments that you selected. Here it also shows you a warning before you commit. And then next we have our connect.json. This is not code, this is our JSON file that we use to connect to the firewall. Here you have to specify the firewall IP and also the username and password. You could either use the API key or the username and password. The API key is better because it's faster and also you don't have to re-authenticate on every request. But if you don't have the API key configured yet, you could use the username and password. Also for this lab, I'm putting the connect.json here so I could show you. But in a real environment, you would want to store this connect.json in a secure path, and then just reference its location in a environment variable and pass the environment variable to Python so that the Python app could read the connect.json through the location path in the environment variable. Okay, so this is our core.py. As you can see from the name, it holds our core classes and utilities. So first we have this utility. This function is the JSON load function. This function loads the JSON file and returns an error if the file is not found or the JSON is invalid. Next, we have this function that I'll come back to later in the explanation. And then next we have the PanoS core class. This class, you could see it has three functions. The first one that it loads the connected JSON file, and then the next one it connects to the firewall, and then it runs this function on the firewall, which is refresh system info. What this function does is that it runs show system info on the firewall, and then it retrieves back the info. As you can see that we log this info here. But this info is not only for logging. The library also uses this info to handle the differences between versions. So like different versions have like slightly different API calls. And then finally here we have the commit function. Since the commit is a sensitive method, we wrap it with our own method. So later we can have any restrictions, but currently we are only logging. Next here we have the base module class. This base module class is the parent of all modules. It has all the stuff a module it needs. First, it loads the connection, and then it also loads the configuration of the module here. And then also it handles the steps. So instead of repeating the steps code everywhere, it's here in the parent, and then also it has a commit. This commit method is used by the main.py, as we saw earlier. So next, let's move to the internet access module. This is the internet access main.py. But actually, before it, let me just show you the config.json. This is the JSON which our main.py takes the data from. Here we specify the values that we want to have configured. First, here we have the host name, the domain, the time zone, and more stuff here. You have the zones, interfaces, and then also here we have a virtual router, address object, NAT policies, and then security policies. Here you could change these values as you want. I'll just change this. And then back to our main.py. This is the internet access class. It inherits the base module, as you could see. So it already got everything it needs. The connection was established and the configuration is loaded. All it does that it passes the module location to its parent, so the parent can also know the location of the config since they're both in the same folder. And then here the steps are defined. The order is important. You can't create the virtual router before the interfaces or the security policies before the zones. So you have to pay attention to the steps. And then here it initializes some variables so all the steps could share the same variables. And then here we have the get methods. And then next here we have the first step, which is configuring the system settings. Here you can see that it's assigning the values from the config.json that we saw earlier. And then it calls the apply XML method. This apply, it runs the edit API, so it will replace the values completely. It will replace anything that you have with these. And then here the next step, you have zones. This creates the zones. And then the next step, it also creates the interfaces, but it also sets the zones to the interfaces. Here you can see this add method, it adds the interfaces to the local XML tree. And then create will run the API to push the interfaces in the local tree to the live candidate config. And then here the set zone does the same thing. So let me run the code. I'll run the first three steps. So let me go to the terminal, open to a new window. Then, okay, this is our terminal. So now let me type python main.py --help. This will display some info about our CLI application. And then now our module is internet access, so we will type main.py and then internet access. And then you run only the first step. But before running the first step, let's check the current state of our firewall. So go to your browser, open a new tab, and then type the IP of your firewall's management interface. And then here enter your credentials. Then wait for the dashboard to load. Okay, now the dashboard finished loading. Let's just close these cards. And then the first step is, let's go to our internet access module. Here you could see the first step is configuring system settings, the one we saw here. So go to your terminal. Let's go to the firewall first. Go to device management, and then here you could see that our general settings are empty. So now let's run our first step. This first step will get these values that you can see: hostname, domain, zone, all of these. It would come from this config.json. So let's start the first step. And here it finished really quickly because it didn't have to commit. Let's just open it again. And then here now the new values are loaded, as you can see. And as I said, this is using the apply destructive method. There's only one system settings object in the whole config tree. So it's okay, let's run it again. Let's remove the auto from here. And let's just keep it as pa-vm for the hostname. And then let's run the first step again. So run. And then let's refresh. Yes, and the hostname is now added. It's now pa-vm. So the next step is our zones and interfaces. So go to network. Here you could see that the interfaces and zones are not configured yet. So let's run the interactive one now. Interactive. Step 2 and step 3. Both of them finished running now. This is the zones and interfaces. So let's go back to our firewall. Go to our zones. And here you could see it created the two zones that were in my config.json. They're both layer 3. And for interfaces, let's double click interface 1. Here you could see it assigned a security zone and an IP version for address. But the virtual router, we did not run this one yet. So let's press enter again. And then let's check again here, go back to the firewall, virtual router. And here you could see one virtual router was created, users to internet. It added the same configurations we had in our config.json. Double click here. The next hop is our home router. And it also added both of the interfaces. So it also linked the virtual router with the interface. So what's left now is the policies and objects. We have the security, NAT, and then also the objects left. So let's just run all of these on once. Let's disrupt this, and then let's just type Python, the same one here, but this time we'll just run the whole module and commit. This also has the commit included. So you could see here step 1, step 2, 3, And here, this is what I was talking about, the thing that's here, it's prompting us to commit. So let's type yes. Actually, before committing, let's test the current status of our inside zone. So here you could see that the policies are created, but it did not commit the changes yet. Here they're still in the candid configuration. The the terminal could commit, but before this, let's check the our client PC2. So it's already enabled, just started here. Click trust. And here type the machine password. Okay, we're logged in. So go to the command prompt and let's check the IP configuration on this client. So type ipconfig, and here you could see it's on the same subnet as as interface 1 of the firewall. Now let's go into our browser to check the internet browsing. So I'm starting Firefox now. So here let's type google.com. I could see that it's not working. It's taking a long time to load. Let's test another application, wikipedia.com. So maybe also cloudflare.com. So all of these websites are not working. So now let's go back to our application terminal, the Python terminal here, and then prompt type yes for the commit. And now it's now running the commit process. Okay, so now the commit finished running. So let's check the client again. Let's refresh the websites. Now you can see that Cloudflare started working. Let's see Google. So Google does not work. This is because Google it's another app ID. It needs a Google-based app ID to allow it. And here Wikipedia is working fine. So let's just quickly add the Google base to our configuration here. Let's try other websites first, maybe pixels.com. Okay, so it works. And then how about github.com? So you can see these websites work. Let's just quickly add the Google Base permission. The Google Base app ID to our security policy here. We could just add it simply. Let's just type Google Base. And then let's go back to the application terminal. And now we'll only run a single step. Let's check what step the security policy is. Let's go back to our internet access module. And here you could see in the steps here, we could see the security policy is step 8. So now let's go to the terminal, and then let's type Python main.py internet access, and you'll want only step 8. Here now it's connecting to the server, and the security policy is now still okay. So now it finished adding the security policy, and here we could see that Google Base is added also. Let's check this in the firewall. So go to the browser, go to your firewall dashboard, and let's double check the policy. Here, you could see that Google Base was added to our application list. If you don't want to specify it, maybe you could switch to using a service model by just allowing the web browsing ports. But then you will need another security rule to allow the ping application if you really need it. But we don't, but we want the ping for now for the lab, so let's just click OK. And we also want the web ID specification, so now let's here and commit. And let's wait for this commit to finish before testing again. Okay, so now the commit finished successfully. So let's close this tab. And then let's go back to our client. Let's go to the Google tab and then refresh. And let's wait for it to finish. Let's just open a new tab. Let's leave this one. Go to a new tab and then type google.com. And now you can see that the title loaded and the page is still taking some time. Let's search about Palo Alto networks. And here you could see that now the web browsing works. I could search and see the results. Okay, this was our lab for today. We took a Palo Alto firewall from bare configurations having only the management interface configured, and we automated the whole configurations all the way to having our users in our inside network be able to browse the internet successfully. So this was our lab for today.